Welcome to today's webinar. Today's discussion will be around a range of subsea hoist. But in the future, what we're planning to do is do the same thing with other products and applications, so we can really go deep, do a deep dive into specifics of each. Our goal for this today is for you to walk away with a good understanding of the technical aspects of this product line. The way we're going to do it is we're going to present a few slides here. Hopefully that's going to take 15-20 minutes, and then we will open it up for questions. So please save your questions for the end. Make notes of those. And with that, I think we can go to the next page, please. Perfect. So these are obviously pre-COVID-19 pictures, as you can see. I'll start by introducing myself. My name is Gus Caldera. I lead business development activities for the Material Handling Organization. I am based out of Brussels, Belgium, and I will now let Mark introduce himself.
Well, morning and afternoon, everyone. My name is Mark Koski. Obviously, that picture is pre-COVID, like Gus said. This is post-COVID. I call it my COVID protest beard. So I am the commercial leader for North America for the material handling portion of Ingersoll Rand's business. And we also have another gentleman with us. We do not have his photograph on there, but you see him live. Tom, please take a minute or so to introduce you.
Hi, everybody. My name is Tom Walsh. I am the Senior Demand Generation Manager for Power Tools and the Material Handling business for Ingersoll Rand.
Excellent. Thank you, Tom. All right. So now we're going to get into some of the meat here. I'll turn this back over to Gus.
Excellent. Thank you. So the first one here is on the material handling history. I'm not going to spend too much time here, but basically to explain how we got to where we are today. And we are basically the merge of three companies. So everything started back in 1924, so almost 100 years ago. The BB Brothers Corporation, founded in Seattle, Washington. We operated out of that facility for many years until just a few years ago when we moved our factory location to a near town called Kent in Washington. In 1926, Ingersoll Rand also started the production of their own winches, and those winches we call today the Classic series. And then in 1947, another company was founded in the north of France. The name of that company was Samia, and we still run that operation out of a town in the north of France called Douai. And actually, that's where this product line, the subsea product line that we're going to talk about today, that's where that line is manufactured. So in '87, Ingersoll Rand acquired BB. In 1990, Ingersoll Rand also acquired Samia. So in a matter of 3 years, we had these three businesses that gave us, expanded our manufacturing and regional outreach. So that is what we have today, the merge of these three companies, and we're still in operation after 100 years. So we can go to the next slide. And on this next slide, I will cover specifically the Liftchain product line. And again, this is manufactured in France, and I'll start with the LCA and the LC2A models there on the left. So first one to talk about is the pneumatic gear technology. This is something we manufacture and we designed ourselves in our factory with our local engineering team. Capacities of these units go from 1 ton up to 100 tons. They're made out of steel for extended durability. The standard design allows the unit to go to -20 degrees, but we do have cold weather units that go to -45, -50, depending on the application. A design factor of 5:1, and that's typically what we use for utility hoist or utility winches. And that implies the chain and everything that is the structure of the hoist. 100% duty rating, available in CE version. So what this really means is that there's a couple of options that are that come with CE. One of them is the emergency stop button that comes independent. The other one is the top and bottom limit switches. And the last piece is the overload protection that triggers at 110 to 125 safe working load of the unit. And then the last piece there is the suitability for zone 2 as a standard configuration, but also suitable for zone 1 with some optional spark resistant pieces. So that includes the control, the wheels, if there's a trolley, or the top hook and bottom hook and block as well. With that, hit the button once more. Okay, thank you. Then we go to the hydraulic hoist line, which is called LCH, so Liftchain hydraulic. And this one is available from 6 tons up to 100 tons. What is specific about this unit is the type of motor, hydraulic motor, that allows the unit to have very good spotting abilities. And is very well suited for integration with PLCs and other automated applications. Then the last piece, and the one we're going to go into more detail today, is a subsea hoist called the SLH for Subsea Hoist. And this one, Subsea Liftchain hoist, and this one is available in 4 capacities, so 6 ton, 12 ton, 25, and 50 tons. Maximum operating depth of 30 meters, waterproof design, and we're going to cover that in more detail in just a second. We also have a corrosion resistant offshore paint, and we'll talk about the classification and what that means, and accepts up to 50 bar or 750 PSI of pressure in the return line. So a very high pressure motor that we operate in these units. It operates at higher pressures than our standard LCH line. So with that, I'm going to turn it over to Mark, who's going to talk about the usage of an air hoist in a subsea application versus a standard subsea hoist.
All right, thank you, Gus. So, as we just discussed, we manufacture air hoists. We also manufacture hydraulic. So why even come out with a subsea version? Well, there's reasons why. We're going to cover very briefly here. Is a lot of people have used and continue to use pneumatic hoist underwater. Well, the subsea has some definite benefits on its side. It was specifically designed for underwater use. So some of the check marks on this page is, it might sound trivial, but produces bubbles. It affects the diver's view. Pneumatic hoist are literally the bubbling in the water. And we work a lot with divers and military personnel, and that's a major restriction. Again, the subsea was created for underwater application. It has internal housings to avoid entanglement, meaning there's not a lot of stuff hanging off the side of it in the way of fittings and other structures. The biggest part is a sealed gearbox. So we're not worried about saltwater infiltration. So unlike an air hoist, if you use that in salt water, you completely have to tear it down in order to clean all the salt water out of it, because that salt water migrates back through the gearbox and just rusts your planetary gears. So we've added some articulated lugs. You can see them in the photograph there, the pink ones. So you can lower it and lift it in and out of position. We use the corrosion resistant chain. Again, these are all standard features on the subsea versus a normal air or even a normal hydraulic. And then some of the smaller items may be overlooked where we've taken the time to look at it. For quick disconnect systems for both pendant and hydraulic lines. All the way to the far left, you see that kickstand. That is a protective bar that protects the QDs or the quick disconnects. And then we take the diver into consideration when we design this panel or pendant. So we're going to look a little deeper into why even have the subsea? So some of the key advantages is it avoids placing the ship in dry dock. So if you have a repair for the hull or a rudder or any of the props, you don't have to take it out of the water. These fixes can be done while you're at sea in the water. So again, very high demand in underwater marine applications. This thing was completely designed and built with safety in mind, with minimum service requirements. So not only for military application, but commercial shipyards, underwater repair, salvage and recovery. So these are some of the applications that we've seen, and people have been buying these subsea hoists. But some of the other ones that we have had some major interest in is some of these offshore wind farms. Those are relatively new. So in order to do the maintenance on it, you're not going to be pulling that out of the water. So now they're using these in order to do some of the repairs. Again, subsea. So add on top of that bridge and dam maintenance and the traditional oil and gas applications for some of these rigs. So let's give it back to Gus for a little while.
Okay, thank you, Mark. So I'll now cover the key differences between our standard hydraulic unit versus this subsea unit. So first off, one of the things our team did was to use an oversized hydraulic motor, like I mentioned before. This allows the motor to still operate successfully, even when there's high back pressure in the system. So this high back pressure is mainly caused by the long lines, the operating line, the feeding line or supply line, and the back line. And the unit allows it to be connected up to 100 meters away from the HPU or hydraulic power unit. And that allows the unit to still operate as we expect it to. As number two, another difference, and Mark mentioned it before, is the complete sealed gearbox, which allows the unit to operate without risk of salt water entering the gear pockets and causing any corrosion inside the unit, right? So this allows for better maintenance or longevity of the unit at the end. Third item there is on the quick disconnects, which allows the unit to be put into position, and then the pressure lines as well as the controls lines can be connected afterwards. So it helps with avoiding tangling of the unit as is located into position. And I think one of the things we can all agree to is that doing anything underwater is much more difficult than above the surface. So respects to these commercial divers that can do this kind of work. And this is why we have made the operation of the unit as easy as possible for divers. So the pendant is a small pendant or smaller pendant than the regular units. And it's got large buttons to operate with gloves. And it's also have thinner control lines, so they're not as stiff when the high pressure is being it goes through the unit. And then the last piece there is the zinc anodes that we have added to the unit to avoid any galvanic corrosion. And I'll show you what that looks like in the next slide. We have an example there of one that is shown after use. So on this one, there's a couple things that I want to highlight. So starting from the top right and clockwise, this unit has a painting system that corresponds to the C5M as per ISO 12944. And this one requires a high durability coating system for conditions classified as very high corrosivity in marine applications. So that C5M is specific to marine. There's another classification called C5I for industrial applications, but of course we use this one that is specific to marine offshore environments. The zinc anodes that we talked about in the previous slide, and if you hit there the slide once again, Mark, we can see a picture there on the bottom right. So this is how it looks after we get that corrosion happening. So the idea is that corrosion moved to this piece of the hoist instead of the corrosion happening in other parts of the hoist. In terms of other features that we can talk about, I think one of the key pieces is the manifold there on the left side. And this one is a very important part of our design. Our engineering team worked on a few iterations of the design until they got it right. And this special design allows the operation of the unit with very high pressure, and it also avoids fluid hammering when the unit is operating at very low speeds, which is the case in a lot of these applications where load position is required, right? So we learned this through many iterations, like I said. Mark can attest to it, as he was also present during the testing of these units. Other factors Mark also touched on are the chain with a grade 80 zinc plated system, 5-to-1 design factor, just as the rest of the unit, and the quick disconnect fittings that we talked about. So if we go to the next one, and we really are looking at three main features that we can talk about before Mark can go into more of the technical details of the unit. So first, the fact that the unit has been designed with the diver in mind. So we went from the typical two-hand hydraulic controls to a one-hand operation design. The buttons are large in size, again, so the diver can operate them with when wearing gloves. The progressive and accurate lifting, thanks to the manifold design that I just talked about. And of course, the fact that there are no bubbles during operation, which is not only a safety concern because of visibility, but an environmental concern, as we heard from Mark. Second point here is built for the harsh subsea environment. So we talked about the sealed gearbox, the internal hosing, the durable construction, and the anti-corrosion features and coating system of the unit. And finally, the flexible plug-and-play design with the quick connects, the small control hoses that allows the diver to manipulate the control and control the unit in an easier way. And finally, simplified installation and removal of the unit. So with that, Mark is going to take us through one of the typical subsea applications that we have seen.
All right, thank you, Gus. So again, these next couple slides, this is where these get used. So rig decommissioning is number one on that list. So again, what's special about it? Yeah, you can go really deep. Again, the waterproof design, all the corrosion resistance for the offshore environment. And again, accepts high pressure. So one thing that we learned in designing this is when you go down this deep, you not only have the hydraulic power unit supplying fluid down to the hoist and returning it, well, that water imparts a pressure on the return line, so that restricts it. So it increases your return line, or what's called the back pressure. So that's another reason we've upped the size of the motor so we can handle that high back pressure. Again, just a list of feature. Ingersoll Rand's starting out with their 6-ton unit, our smallest unit, and the best closest competitor we could find is where we're a single strand of chain, they're using 2. And you go down this list, and everybody can read this, so I'll just short circuit this a little bit. I know that all the other units, including what we used to do, is we would supply a standard air hoist or a standard hydraulic hoist and use it in a marine application. And that's why we developed this subsea, in order to alleviate a lot of the problems that we found. Again, just some of the text and specs on it. Again, available 6-ton, 12-ton, double stranded, 25 double, and 50-ton quadruple stranded. That gives a lot of the speeds, flow rating and pressure for the hydraulic fluid, weights, And this is all available in the brochure for the Subsea. Again, how do you order it? So SLH is Subsea Liftchain Hoist. Also, some people say hydraulic, but that's the only way this comes. Again, the size and capacity and the number of strands. So 060, single stranded. Ranges for industrial control, again, only available with that progressive pendant right now. And top hook, and just specify how many, or a height of lifts, or how much chain do you need on it, and control length. So again, that's where we stand for now. Just wanted to highlight some of the differences. And right now we'd like to open it up for Q&A.
Just so everybody knows, there is a Q&A button at the bottom of your screen. You should be able to just type in your question there. And while we wait, guys, I did have one question as you were going through this. I love the slide on the applications for this type of hoist. When you guys, I guess, are at any end users, do you see any common questions pop up when it comes to these subsea hoists? Like, what is the most, I guess, common misunderstanding about these hoists that customers have?
Well, I'll take that one. It's the biggest misconception is people think it's still a standard air or hydraulic hoist. So they're used to having to do all that maintenance, even though it's a major burden. There's just been nothing on the market, to our knowledge, ever for this environment. That's why they've been utilizing some existing equipment, and that's why we developed this. So, I mean, we do have permission. It started with the U.S. Navy. That's why they came to us to develop something that they would not have to take apart completely every time they used it. I mean, literally would take the gearbox apart, wash out all the salt water, re-grease everything. It's like doing a major overhaul every single time you use it. And
Wow.
That's what this avoids.
Awesome, thank you. We do have a question from Steve from Ballard. Is a chain bucket available?
Oh, again, I'll take that one. In fact, it's perfect timing. We have inquiries we're working on just today, and we have not provided chain buckets yet, but the answer is yes. Since it was built on the Liftchain platform, the standard chain containers are available and we can bolt them onto this. The only difference is that we're offering them in stainless steel for kind of obvious reasons. You don't want to have any kind of galvanic action affecting the chain container also. So, you know, again, short answer, yes. But again, stainless steel.
Yeah, I guess to add to that, it would only apply to, recommended to use a chain bucket on vertical lifts, right? So when pulling from the side, et cetera, which is a lot of the cases, these operations will require this side pulling, then having a chain bucket can be, first, it's a constraint because of mobility and all that, but it also can be a safety hazard because the chain can come out when operating the unit, hurting somebody. So that's also something to keep in consideration when using a chain bucket in these type of applications.
Yep. Thank you, Steve.
Any other questions out there? That was currently it for the Q&A queue. All right.
Well, we'll leave it open for another minute or so because as we promised,
we did get one more question in here, again from Steve, and it is, what is the delivery for these subsea hoists?
Right now, these are built to order. And lead times right now are the 6 and 12 tonners are running about 8 to 10 weeks to build. And the larger ones, the 25 and 50 ton, They're running a little bit longer, approximately about 12 weeks, ready to ship from Douai, France. So, yeah, any more? We got about a minute left. Like I was saying, as promised, we're going to finish on time. Mr. Cap.
James did bring up a good question. Yes, we will be making a recording of this presentation available afterwards for anybody that was not able to attend that you think would benefit from some of this information.
Yeah, we'll send the recording or the link to the recording. I think we can also add more material to it, like the brochure, and the presentation is also available. If we can send it out, I think that's also be helpful for people to have. So we'll send a PDF of it.
Mm-hmm. All right, with that said, Gus and Mark, thank you guys very much for your time and for walking us through some of the more technical aspects of the Subsea Hoist. We look forward to doing some more of these webinars in the future. So for those attendees, please keep an eye on your LinkedIn and your email inbox, and you'll see some new invites coming up shortly. I believe the next one in about 2 weeks.
Excellent.
Yeah, in about 2 weeks, look for another invite. So thank everyone for your time.
Yeah, thank you everybody, and you'll hear from us in the future.
We'll see y'all next time.